General framework, current schedulers are designed in two steps: time domain packet scheduling and the frequency domain packet scheduling. We have developed the same approach, but a little bit principally there are a lot of things we counted. The bandwidth and QoS aware uplink radio scheduler. Let's look at inside of the time domain part of it. You can see that weighted proportional fair matrix algorithm we use to prioritize the users. So there we consider the QoS weight, quality of service weights, which includes rate budgets and delay budgets and also delay thresholds. We have to consider for some application depending on the applications. And also channel condition of each and every user. And also the fairness aspect. This all has to be considered for today's schedulers. So let's look at a little bit about formulas on this. I focused this, I simplified the formula in such a way I can explain to you that we consider the channel condition. This R instantaneous means channel condition if you current achievable, maximum achievable data rate, if you are given a bandwidth that you can handle. That you can handle means your mobile may be not able to cater full bandwidth, might be half of the bandwidth because power is limited. So then the other aspect, the fairness, because you get the R average value. You divide by that. So then you try to give the fairness to the users. For each individual users, we have to get this matrix. And then the weight factors, this consider with two parts. One is delay budget. The other one is the rate budgets. Because if you have an average throughput and also the current and the budget, based on whether you are above this budget or lower, the factor can be greater than 1 or less. The other case is the reverse action when the delay, because delay also we have to consider as a factor. So there is another factor called rho, which means if you exceed certain delay, we consider that as well. So if you have any questions, we can go to the question session and I can explain a little bit more in this. Let's look at the frequency domain part of the scheduler. There we have already done this time domain part. And now we have to allocate the spectrum. You know, we have the spectrum with small subcarriers, depending on the size of the bandwidth. So we have number of resource blocks. Resource blocks mean we have, for example, 14 symbols for 1 millisecond, and we have 12 subcarriers together. This is we call kind of physical resource block, but the smallest one is half a millisecond. So each and every resource block, for every user, we have to get the frequency domain matrix. That means if you have, for example, 20 megahertz bandwidth, if you have 100 PRBs, for each and every user, single user, we have to calculate what is his capability, what is his matrix. And if you have 2,000 users or very large number of users, you can imagine how this is complex. So depending on the complexity, we also, depending on the operators, we also allocate resource chunks. That means it can be 2 or 3 PRV blocks. So we use also, when we have those matrix, then we also have to choose the priority. So we use unique depth first search algorithm to find the best possible combination. So under these three constraints, for example, contiguity constraint, power constraint, and buffer size constraint. I just give a brief one example to understand this. Let's assume we have 2 users and 3 chunks, not the 100 chunks, something like that. So then we have the matrix value as given there. For user 1, chunk 1, 10, 6, 5, and 9, 8, 3. These are just the matrix values that we achieved. So all the possibilities are listed the right hand side. So when it's come to the contiguity constraint, that user cannot use, it may be the case that user cannot jump over the PRBs or chunks. For example, 10, 8, 5. Because then the first user 10 and 5, they are far apart. We cannot do that. Due to the contiguity constraint, we can lose 2 branches here. So then we can evaluate the next constraint, power constraint. Due to the power constraints, it is maximum possible usage is 2 chunks. So there is another constraint coming in, so the user cannot use more than 2. So then further it's reduced. Then at the end, you can see what are the possibilities that the user have. Only 2 users with 3 chunks. And then we know the right choice now. Now, according to our formulas, we get the right choice. So this is the configuration. This is the allocation of the frequency. Let's look at the simulation results in brief, since we don't have that much time. So this is our simulator, which I developed basically, and also now continuing with my research group. So these are the parts of the protocols. And these are the simulation results. And we got the scenarios. We increase in the load, the single bear connection and multi-bear connection. We increase the load, and we perform the simulations. You can see that we straightforward. We can throw it away. There are 4 schedulers we checked with our one, comparing the our one. So you can see that the empty maximum throughput scheduler and the blind equal through schedulers, we can straight away we can throw away because they have less performance. And here we are using spider chart in order to give the overview. Otherwise, we have to go individual results and analyze with the confidence intervals and all this analysis. So all these results, this is a single bearer results and the multi-bearer results. All these results will tell you that the bandwidth QoS aware scheduler performing better, because we are much concerned about voice calls. We should avoid any any disturbance for the voice call and also video conferencing calls. So data we can a little bit tolerate. You can see optimum performance can be highlighted with this new scheduler, which consider all the factors. Let's look at how the machine-to-machine can be cooperated with this. You can see the scheduler algorithm already complex. So how we integrate this, all the messaging and a huge amount of data. So of course complexity increase. So we can have additional hardware. Of course this is a temporary solution. It's very costly, but we also can have the other part that we define the section-wise scheduler. That is the proposal from our side. This is still under investigation, which consider all the type of applications. So let's summarize. I will not go in detail with summary. I already pointed out what are the applications that we have and where our focus is. This LTE uplink scheduler, and the scheduler, designing this scheduler is today very complex task, and we achieve required QoS targets. And also for the disaster management cases, we have to include emergency priorities. So the new proposal mostly providing the estimator, good estimate, knowledgeable estimate, adaptive estimator, and also consider the memory aspect. So with that, I'm sorry to take a little longer. Thank you very much for your attention.
Thank you, Tushara. We will have the questions at the end of the session. So that was a very interesting paper addressing a very important area, M2M communications.